Hey everyone, and welcome to this Masterclass Explainer. Look, today we're absolutely demystifying Snowflake's data cloud. And if you've ever felt kind of bogged down by the sheer weight of cloud computing concepts, don't stress. We're going to break this whole shebang down using a super relatable analogy, running a massive, high-volume restaurant chain. Think about it. Millions of daily sales transactions, just endless streams of e-commerce orders, health checks rolling in. How on earth does a system process all of that, seamlessly handling the ETL pipeline to extract, transform, and load that data without just completely crashing? Well, that's exactly what we're mapping out today, step by step. So here's our game plan for today. First up, the Snowflake anatomy. Second, sizing your muscle. Third, we'll hit auto-scaling and queues. Fourth, roles and access. And we'll wrap up with retention best practices.
Okay, let's dive into this. Section 1, the Snowflake anatomy. Brain, muscle, and storage. To really wrap our heads around how Snowflake manages data, we've got to look at its unique three-tier architecture. It's actually a lot like a well-run restaurant, because Snowflake completely separates its operations. Up at the top, you've got cloud services. In the middle, query processing, which is powered by virtual warehouses. And down at the base, the storage layer. By keeping these layers totally distinct, you can scale up your computing power without having to constantly shuffle your underlying data around. It basically ensures no single department ever gets overwhelmed. Let's compare those top two layers, because this is key. Cloud services is the brain of the operation. Think of it as the restaurant's general manager, handling the infrastructure, locking down security protocols, and, absolutely crucially, optimizing the queries for the best possible performance. It doesn't actually cook the food, right? But it orchestrates everything perfectly. On the flip side, query processing is the muscle. These are your virtual warehouses. This is your busy kitchen staff executing massive parallel processing. They take thousands of data queries, your customers' orders, and they do the heavy lifting to cook them up and deliver the results all at the exact same time. In supporting both the brain and the muscle is that lowest tier, the storage layer. This is your master pantry. It comes complete with internal and external stages for loading up those bulk data deliveries. It's where all the raw data, the actual ingredients for your business, like years of daily sales or customer records, is kept incredibly safe. Snowflake stores all of this in what they call hybrid columnar blobs. Basically, that just means it is highly compressed, perfectly organized, and ready for the kitchen to pull from at literally a moment's notice. All right, moving on to Section 2. Sizing your virtual warehouses. Let's talk about flexing that compute muscle.
Now, what's really interesting about this slide is how Snowflake makes visualizing compute power just incredibly simple. They use a familiar t-shirt sizing model. Instead of getting bogged down in complex technical specs, you just progress from extra small to small, medium, large, extra large, and all the way up to a 4XL. Now, each size up does cost more Snowflake credits, which is how the computing is priced, but it gives you exponentially more stoves and chefs to cook those complex data queries faster. If your kitchen needs more capacity, you simply size up your virtual warehouse. To put the sheer scale of that into perspective, I want you to think about this massive number, 128. An extra small virtual warehouse runs on just a single unit of compute power. But if you're processing astronomical amounts of data and you upgrade to a 4XL warehouse, you are instantly flexing 128 times that compute power. It's literally the equivalent of upgrading from a tiny food truck to a massive industrial-sized commercial kitchen with just a few clicks. Pretty wild, right? Which brings us to Section 3, multi-clustering and auto-scaling. Handling the lunch rush. Okay, picture this. It's Black Friday, or it's the daily lunch rush at our restaurant chain, and suddenly thousands of analysts are querying the data at the exact same time. A queue forms. It's just like a line of hungry customers backing up out the door. Now, a single virtual warehouse cluster can only handle so much at once, which is exactly where Snowflake's multi-clustering feature swoops in as this brilliant relief valve to save the day. Here is the exact chronological sequence of how that auto-scaling actually kicks in to handle the rush. First, a query gets queued up because the current cluster is maxed out. Second, that cloud services brain we talked about, it detects the overload. And third, auto-scaling dynamically boots up an entirely new, identical cluster of compute power right alongside the first one. It's literally bringing a second, third, or even fourth team of chefs online on the fly to clear out that backlog of orders so nobody's left waiting. And this brilliantly illustrates that you actually have control over how this auto-scaling behaves. Snowflake gives you two very different mentalities to choose from for your scaling policies, standard and economy. Let's break down this crucial trade-off. The standard policy? That's your rocket ship. It prioritizes sheer speed and performance, booting up new clusters immediately so absolutely nobody waits. The economy policy, on the other hand, is your shield. It's all about conserving your budget. If a queue forms, it actually waits 2 to 3 minutes to see if the current clusters can catch up and redistribute the load before it spends your precious Snowflake credits to start a new warehouse. So it basically works smarter to save you money during those temporary, short-lived spikes. Let's move to and see how this builds into Section 4, Managing Roles and Access. Who exactly holds the keys? Snowflake uses a very strict hierarchical access control system to make sure sensitive info stays totally secure. Up at the absolute top, you've got the account admin. That's the ultimate master key for your entire environment. Right below that, the sysadmin manages objects like databases and warehouses, and the security admin manages global roles. Now, because these are top-level roles, best practices dictate they must be heavily restricted to a very small, trusted group of users. Further down the chain, you have the user admin, who is dedicated purely to creating new users. And finally, the public role, which is just the baseline default, automatically granted to everybody. And finally, Section 5, Data Retention Best Practices, Keeping What Matters. So, the crucial point is this. Because Snowflake separates storage from compute, storing data is relatively cheap, but hey, it's still not free. We really have to balance safety, historical tracking, and cost. Like, how long should we actually keep our data before letting it go? Well, knowing exactly what type of data you're dealing with is key here. Snowflake provides very specific best practice rules for data retention periods, and they utilize features like time travel to protect you from those dreaded accidental deletions. Let's detail these out. For a staging database or large high-churn tables, think of this as messy, temporary data, kind of like the scratch pad your waitstaff uses to jot down orders before putting them in the main system. You want a retention period of 0 days. Set them as transient. Do not pay to store that stuff historically. But for your production data, your actual, finalized, super important sales records, you should maintain a retention period of 4 to 7 days with an absolute minimum of 1 day. That ensures you have a reliable backup window to recover critical info if someone messes up, but without bloating your storage bill indefinitely. And that brings us to the end of our breakdown. From separating the brain and the muscle to dynamically scaling up those virtual kitchens and locking down your data security, Snowflake just offers incredible tools. So I want to leave you with this provocative question to chew on. Is your current data warehouse working harder or working smarter? Take a moment to reflect on your own architecture, consider these best practices we talked about, and hey, thank you so much for engaging with this Masterclass explainer. Keep learning, keep building, and I'll see you next time.